formation reactions are reactions where you have an element and another element forming a compound. Now the compound could be ionic or molecular. Usually we'll be looking at the ionic compounds because they're a little bit easier for us to sort out, and we tend to use them a fair bit. If it was going to make an ionic compound, it's going to be a metal plus a nonmetal to form that ionic compound. If it was going to be a nonmetal and another nonmetal, then it'll form covalent bonds to make a molecular compound. Now, in a metal to a nonmetal, electrons are going to be going from the metal to the nonmetal, and we end up with the metal having a positive charge and the nonmetal having a negative charge. So these are called cations, and these are called anions. And they're held together by their opposite charge, and they'll always form an ionic compound in the lowest common terms, so that you have an equal amount of charge. If you watch the videos that are on ionic compound formulas, that should make more sense. For nonmetal and a nonmetal making a molecular compound, these are going to have shared covalent bonds, and the predicting what the product is harder with nonmetals. So sometimes you won't really know. But let's say that I had was going to make methane. CH4 is methane. That's a molecular compound. Carbon is a nonmetal and hydrogen is a nonmetal. It would be made from carbon solid and hydrogen gas. But hydrogen gas, when it's by itself, is a diatomic element. So this will be carbon, the element, plus hydrogen, and hydrogen is a diatomic molecular element. And then to balance it, I'm going to need two of these. Whereas if I had a metal, let's say calcium, and I reacted it with oxygen, it's going to make calcium oxide. Now, calcium is a monoatomic element. Oxygen is another one of the diatomic elements. And the calcium oxide is made from calcium ions, which have a Ca2 positive and an O2 negative for the oxide. Since these are a 1-to-1 ratio, this will be calcium oxide solid. And that's the basic concept for all formation reactions. The places where people make mistakes are that for the elements, we have H2, N2, O2, F2, Cl2, Br2, and I2 are the diatomic elements. They're molecules, but they're still elements because it's only one kind of thing. And then P4 and S8. And these are the polyatomic elements. All other elements are monoatomic. And so you see here, when oxygen was by itself, the pure element, it has to be diatomic. Hydrogen here is diatomic. If I had sulfur reacting, so if I had sulfur and I reacted it with, let's say, magnesium, magnesium is a monoatomic element, so it's just going to be MgS, plus sulfur is S8, and it's a solid. And it's going to make magnesium sulfide, which is an ionic compound that takes MgS and it's a solid. And the reason that it's just 1-to-1 is magnesium has a 2 positive and sulfide has a 2 negative. So one of each balances out the charge. if you can keep track of the elements, what their formulas are, and then figure out what the products are, particularly with ionic compounds, formation reactions are reasonably straightforward to set up.